Our speaker today is Mike Reagan. He's been in the industry for
37 years.
37 years. Mike's one of our outside sales guys and works in the Southeast Kansas area as well. He's worked with Train for a very long time. So he actually helped put this presentation together for Train. So he has lots of experience. Again, he'll be happy to answer your questions. And if you want to stay after, like I said, we'll have more design mechanical people here for you. So with that, it's Mike Reagan. Thanks.
Thank you. Get a quick sip here. Thanks. This is a great turnout. Thank you very much. And today I want to talk about a topic that's near and dear to my heart, chiller operating logs and their analysis. And there's two goals I hope to get out of this. The first one is to show the value of taking at least daily operating logs. And the second one is to be able to think about the data rather than just writing down numbers. Now, this presentation is going to focus mostly on water-cooled chillers, although it's just as important to log air-cooled chillers. And again, these are just some sample logs, and just because it's a Train chiller log may not be applicable to all Train chillers. That was a Train centrifugal chiller log. I believe I had a sample Carrier screw chiller log on the back side of that. So there are others. Someone had asked about McQuay. We've got a whole database on our network server of literature from all the different vendors, and I looked through most of those, and I couldn't find in the McQuay literature a McQuay log sheet. So I did look, because that was mentioned before we started. So anyway, just for what it's worth. Anyway, what is an operating log? I like to think of an operating log as a medical report on the condition of your chiller. And why is an operating log important? Because it can provide early detection of operating problems before they become severe enough to cause chiller shutdown or possible failure. And this is where I mentioned my second goal was don't just write numbers down, think about them too. The story from years ago that I had heard was a contractor got a call from one of their customers, and there was water all over their chiller room floor. And when they got out there, they found that they had froze the evaporator. And they said, geez, I don't know how this happens. We're logging the chiller every day. And sure enough, they had a custodial person go out, and they instructed them how to take numbers off and write everything down. And when you look at the log, you saw on the evaporator water temperature each day, 38, 35, 32, 28, 26, 26, 26. He was just told to write the numbers not down, not to think about them. The other thing is, and another item I'll throw out at you, everybody is concerned of first cost on their preventive maintenance programs, and they always want a chiller startup and then a boiler startup, and let's skip that summer inspection. An operating log is kind of like an EKG, okay? How many have had an EKG? Okay. There's two different kinds. There's a kind you lay there on the bench in your doctor's office and he takes an at-rest EKG, but he needs to see different information sometimes, so he'll get you on that treadmill and do a stress test. He actually sees a totally different heart on that treadmill than he does when you're at rest. Same is true for chiller operating logs. If a tech goes out there who knows how to interpret these logs, and he's out there doing the initial startup for the summer or for the spring, and he's logging usually a lightly loaded chiller. But boy, if he was out there in July and August, he'd be logging a totally different chiller under full load. And there's a lot of value to that a lot of people choose not to invest in that summer inspection, that is something I think is worthwhile. So just for what it's worth. What types of problems can be identified early by good logging procedures? Well, you can catch air leaks, loss of refrigerant, electrical problems, low or unbalanced voltage, unbalanced amp draws. You can identify improper water flows, either in your evaporator and or your condenser. You can see if it's a pump problem, a strainer problem, or a valve problem. You may be able to find control problems, improper control settings, control set point drift, which is less of an issue in today's microprocessor world, but nonetheless still something you have to be aware of, or control failures. Maybe there's a sensor that's kind of separated itself from the pipe a little bit and not getting a good reading anymore. Improper heat transfer. You might be able to identify fouled tubes, or if there's air in the system. Lubrication problems, loss of oil or loss of oil pressure. So those are all the kinds of things that you can find potentially with analyzing a good, at least daily operating log. What information do you need to make a chiller operating log? Well, the first thing you want is original chiller design information. And particularly on the larger chillers, they were built to order, and they actually had a selection specific to that application. Now, I had an example here of one for one of my clients. Down in southeast Kansas. This is a 300-ton York centrifugal that was 15 years plus old. So I was able to get the performance data, the amount of refrigerant, the amp draws, all the water and pressure drop conditions. So these are available from the manufacturers. If it's a smaller unit, you can at least get the catalog data and come up with, or look on the drawings and see what the engineer originally designed the parameters to be for that application. You want the actual chiller operating data, which is what the information you're going to get off the chiller, and a typical chiller log form. Like we said, this happens to be a trained centrifugal chiller log form. And the nice thing, it gives you your date. Some of them, and I like that, it has the time you took it to. See if my laser pointer works. There we go. Having the time too is good. You want to pick the same time every day, ideally, or around the same time. So if you start logging in the afternoons, which might be a good time to do it, mid-afternoon, log it every mid-afternoon. Nothing's wrong with logging it in the morning, mid-morning, and in mid-afternoon. You actually may see two different chillers depending on how it's loaded. Number of run hours, number of starts, and the collection of data that we'll talk about in a little bit here. And if there's any comments you want to make, you know, it was noisy or something, you can put it down there. And each day is another line, so you can just look right down here and see trends. That's why someone made the comment, well, now they have this on computer. What I've seen is a lot of manufacturers have a printer interface capability where you can download a report that has all that information. But you got all these strips of data all in this big pile in this file folder, but you can't see them all in one. You just can't see trends because they're not all lined up together. So there is an advantage to going and having a daily log sheet. Usually people print out several of these and put them on a clipboard on the chiller. Again, that chiller log form has the design data as well as the operating data. The operating data is what you put in the lines, and at the bottom there, you'll see the original design data that you can use as a benchmark as to how you're doing. Location of measurements of operating logs. Here's some of the things you're going to measure. You got temperature measurements. You want to know your water temperatures, both in and out. You want to know your refrigerant temperatures of both high side and low side. You want to know your oil temperature. You want to know your pressure measurements. The differential pressure across your evaporator on the water side, the same for the condenser. You want to know your refrigerant pressures, evaporator and condenser. Many of the chillers today will have temperature sensors in the refrigerant circuit, and then they will extrapolate out and calculate what they think the pressure is based on the saturated condition at that temperature. You want to know your electrical voltages and amperages, and you want to know your controls. Some proper measurement techniques and considerations. Again, all data needs to be taken at one time. It's like a one-time snapshot. You don't want to take half the data and then come back an hour later and take the rest. You need to take it all at one time so you can see a snapshot of where you're at. Also, the machine should be at a stable load condition. You want the time for the system to balance. You don't want it while it's hunting. And particularly if you're first turning the chiller on, you want to give it 20 minutes to 30 minutes for the system to stabilize before you do a log. And your thermometers must be calibrated, as well as your pressure gauges. And you want to be aware of your location of gauges and how the effect of valves and elbows nearby can affect the readings, or if you're in a high altitude situation, the effect of altitude on the gauge readings. Here's a pictorial of an old train chiller, a centrifugal chiller. Again, you have your temperature and pressure gauges on both the entering and the leaving on the condenser. The same for the evaporator. You want to get a refrigerant temperature on the condenser and for the evaporator, and an oil sump temperature if you have particularly if you have a separate oil management system on your chiller. Not all chillers have that. This may look like Greek to you, but every chiller manufacturer provides a nomograph like this. And when you're taking that pressure reading across the condenser, for instance, this is an evaporator. You take your pressure drop across the evaporator, and you will come in, let's say it's 15 foot of water, and you come across here and you find that you have this particular, oh, it's easier to see this one, this J1-2 vessel. Then you come over to that line, come down, it tells you what your flow is, 1,000 GPM. So you can highlight the particular line that's on for your chiller, and knowing the differential pressure, be able to determine the flow going through that chiller. Now, just for what it's worth, most manufacturers list their pressure drops in foot of water, but most gauges are PSI. So 1 PSI is equal to 2.31 foot of water, if you want to make a note of that. And again, 1 PSI is equal to 2.31 foot of water. And conversely, 1 foot of water is equal to 0.433 PSI.